All right, hopefully I'm audible. Please let me know if I'm not, and I hope I am. I hope I am nicely audible. Yeah, just let me know in the comment section if you can hear me, guys, if the sound is okay. If not, let me know as well. Let me just disconnect from here. Maybe that's... All right, here we go. All right, so guys, we are continuing on with grade 11 geometry, because we started grade 11 geometry, I think, was it in the week sometime? And there's a beautiful video that I've posted up in the YouTube channel, which basically kicks us off on the first two theorems that relate to Euclidean geometry, and I explained those, and I would really encourage you. The video has been doing okay, I think, you know, amongst the many videos that I do post. I think that one has been receiving a little bit of attention. I'm guessing people are also searching on YouTube quite viciously, wanting to figure out this grade 11 geometry topic, because, you know, those who are self-starters, who are not waiting for their teachers to actually kickstart them off on the syllabus, are already jumping onto various platforms, exploring all the topics in the annual teaching plan, and they are making their efforts that they need to make. And I really commend you guys for that, you know. Really commend you for that. You must keep that up, because at the end of the day, the more ownership and the more initiative and you take for your education, the better it is for you. All right, you don't have to solely be dependent on your teacher physically at school, though that is something that is helpful, obviously. But if you can actually kickstart yourself and push yourself, then that's good. I mean, this in and of itself, you joining in a platform like this is also an indication that you are willing to kickstart your own sort of like learning for the coming term. So I commend you for that. So guys, like I said, please do go and check out that first video, because I introduce the topic of geometry. I go through sort of like a circle. I go through the components of a circle, the fact that we have the radius, we have a center, we have what we call a chord, we have what we call a secant, a segment. I explain all of those bit of components so that we can familiarize ourselves with what a circle does have. All right, because in grade 11 our focus is on Euclidean geometry, the circle part of the geometry, but we need to understand that all the theorems that we've established in previous grades are of still utmost importance. So you guys need to also be you know, you need to be on, your understanding needs to be good of those earlier concepts. Okay, everything that has to do with the lines, everything that has to do with parallel lines, your triangles, your quadrilaterals, all of that theory needs to be up to speed. Congruency, congruency of triangles, and all of these other things that you established, your properties of your quadrilaterals. You guys need to be good with your understanding where those concepts are concerned, because this is like we are adding on another layer to our building in grade 11 for our geometry, and in grade 12 we put on a little bit more as well. So let's look at a question that relates to what we covered, because there were two questions that I then said people must do for homework, and I want us to actually look at those before I jump into what I have today as the theorems are concerned. So here we have AB. We are told AB is a chord. Now you see, these are terms that I explained in the previous video. What is a chord? A chord is a line that comes from one end of a circumference. We call this a circle, but the distance around a circle, we call it a circumference. And what a chord is, it is a straight line from one end of the circle to the other end of the circle. So that line that basically is drawn from one end of the circumference to another, we call that a chord. So we were told that AB is a chord, and obviously if you go to the diagram, you see AB, that is definitely a chord. So AB is a chord of a circle. Here is the circle with center O. So here we know that this is the center. Okay, very important. OE, as it says, OE is here, OE. We are told that OE bisects AB. The word bisect means to cut into half. So OE, here is OE, guys, the line OE. What does OE do? It bisects AB, which means, in other words, that this line is cutting this line into half, right? Then we are told AD. Here is AD. Okay, forgot the letter D here. AD is equal to 12 what? Centimeters. ED is equal to 8 centimeters. And there it is. And OD, which is just here to there, is equal to X. Now we are asked to determine the radius OB. So where's OB? Here is OB. We are told that OB is a radius. We are asked to determine the radius of OB, and we are told to determine it in terms of X. In other words, we need to write the length of OB so that in the expression or in the answer of OB, there's an X that is there in the mix. So if we look at OB, what is OB? We are told that OB is a radius. Now, by definition, what is a radius? A radius is a line that comes from the center of the circle to the circumference. This OB is referred to as our radius. All right? That's what a radius is. And these are things that I explained in the previous video, where I explained the different components of what are contained within and without a circle. So the radius is OB. Then we are told we need to write OB in terms of X. Now, if we look at the entire circle, OB is not the only radius that's there. Another radius that we can see is OE. OE is also a radius. Why do we say OE is a radius? It's not like in the statement above we are told that OE is the radius, but there are things that we are told about OE. We are told that OE bisects AB. So this line OE cuts AB into half. That's one thing we are told. We are also furthermore told that OD, which is OD, a part of OE, is equal to X. And we are furthermore told that ED is also equal to 8. 8 what? 8 centimeters. So with that knowledge, guys, and with that understanding, how then can we go about to calculate the length of what? Of OB in terms of what? In terms of X. This is a beautiful big question. So OB we know is a radius. We also know at the same time that not only OB is a radius, but we know also that OE is also a radius. But not only that, OA is also a radius. Now there's something interesting that we know about the radius of a circle. All the radius of a circle will be equal in length, all right? And that's very important to note, that all radiuses of a circle are actually equal in length. So like I said, OB is a radius, OE is a radius, and OA is a radius. And that's just something I wanted to sort of like state so that we all know that these are radius. But now we are asked to actually find the length of OB in terms of x. Now check this out. OB, all right, we can find the length of OB in terms of x. And the way we are going to go about that is in the following way. So I'm sure you guys can see that OB is actually where a triangle is formed. OBD. This is a triangle. Furthermore, there's something else that we can actually say, and this is the following thing. We can actually say that OE, the line OE, is perpendicular to AB. The line OE is perpendicular to AD. Now some of you are going to be like, Haibo, how can that be? The line OE is perpendicular to AB. How can that be? The reason is because there is a theorem that I did in the previous lesson that says a line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. I repeat, a line from the center of a circle to the midpoint of a chord, AB is the chord and D is the midpoint of the chord. If a line is drawn from the center to the midpoint of a chord, then that line basically is perpendicular to the chord. So I'm going to say OE is perpendicular to AB, and the reason why I say that is because line from center to midpoint of chord. Line from center to midpoint of chord. Yes, this is grade 11. Then because of that, guys, of perpendicularity, I can then put my perpendicular symbol to indicate that angle AODB is actually equal to 90 degrees. I mean, that's what OE being perpendicular to AB actually means for this angle. It means ODB is 90 degrees. The angle ODB is 90 degrees. I hope that makes a lot of sense. Now, what else did we know, or what else were we told in the statement? We are also told that AD is equal to 12 centimeters. But if AD is actually equal to DB, then it stands to reason, because if OE is bisects AB, it means that AD is equal to DB, which is equal to 12 centimeters. That is so given to us. We are given that information, all right? We are given that information. This is 12 centimeters. DB is 12 centimeters. So that means I can fill in that 12, okay? Now, you see this triangle, it's a right angle triangle. What I have in that right angle triangle is 12. I have OD, which is X, and I have OB, which is actually called the hypotenuse because it's my radius. Opposite the 90 degrees, I have an hypotenuse. So this is what I can do. I can then say in triangle, which triangle? Triangle ODB. I can say the following. In triangle ODB, OB squared is equal to DB squared plus OD squared. OD squared. What's the reason? The reason is Pythagoras. Pythagoras. OB squared is equal to DB squared plus OD squared. So now OB, guys, is equal to, what's DB? DB is 12. So we say 12 what? 12 squared. And what is OD? OD is equal to X. So we say X squared. Now when we apply 12 squared is equal to 144. What's X squared? It is just X squared, guys. That's what it is. And then because we have a square, we can take the square root on both sides. And when we do that, we know that because this is an equation, we can put plus minus. But ultimately, we know that a length can never be negative. So our negative sign, we are just going to ignore, and we are going to embrace very strongly our positive sign, which means OB in terms of X is actually equal to the square root of 144 plus X squared, right? And that is simply the length of OB. All right, so I just want to backtrack a bit so that you can see what it is that we did in order to get to this length of OB. Okay, so first and foremost, we looked at the diagram. We saw that there's a line from the center that bisects a chord. And seeing as though that is the case, we know that this line from the center that bisects a chord, we know that there's an angle that is formed that we did not know, but we know because of the theorem that says a line from the center to the midpoint of a chord, what does it do? It is perpendicular to the chord. So therefore, we can note that this angle here is 90 degrees because OE will be perpendicular to AB. Why? Because line from center to the midpoint of the chord. That's why we said OE is perpendicular to AB. Then obviously, explicitly stating that angle ODB is 90 degrees. Pakati inside the 90 degrees for our triangle there. Now that we have a right angle triangle, it's a matter now of checking out what are the different lengths of the sides of that triangle. We had learned that this AD is 12, and because DB is equal to AD, because of the fact that this line bisects AB, then therefore we can say that DB is equal to AD, which is equal to 12 centimeters. Why is that the case? It's because that information is given to us. Definitely, we'll always upload, guys. Okay. Then in triangle ODB, which is the triangle we can now focus on, because what were we asked in the beginning? We were asked to determine the radius of OB in terms of X. We then proceed and then use in the triangle, we go and see, oh, right angle triangle means we can use Pythagoras. So we say OB squared, which is, we are wanting to find the length of OB. So it's nice that OB is in the mix. OB squared is equal to what? DB squared plus OD squared. What is DB? DB is 12. So we say 12 squared. What is OD? OD is X. So we say X squared. And remember, our reason is Pythagoras for the new statement that we have written. Then we simply simplify. 12 squared is 144. X squared is X squared. Then because we have a square, we want to get rid of the square, so we take the inverse of the square, which is the square root. But what we do on the left, we do where? On the right. Not forgetting our plus minus, but because we know that this is a length, it should be a positive magnitude or length. We therefore ignore the negative sign, embrace the positive sign, and our final answer for OB is the square root of 144 plus X squared. And we leave it in this state. This is OB in terms of x. So this notion of in terms of x, this is a very famous notion where they say find something in terms of another variable. It means that in your answer, x must be in there. Now the follow-up question to that is that we need to then solve for the value of x. What is the value of x? What now is the value of x? So now that we found OP, they are now asking us to find the value of x. All right. Calculate the value of x, which is very, very important. Okay. Or in other words, actually not really the value of x, but to calculate the length of OP, the actual length of OP. You see, initially they asked us to find OP in terms of x. Now they are asking us to find the actual length. Okay. What is the actual length of OP? So we use the knowledge that we now have of the radius. I'm sure you guys can see that this is OB, this is a radius. This is OE, this is also a radius. This is OA, this is also a radius. So I'm sure you guys can see that OE, for instance, our radius here is simply this length of OD. So OE is actually equal to OD plus DE. Okay, because these are parts of the radius. OD plus DE. That means x plus 8. That is the length of OE in terms of x. But we also know that OE, which is the radius, is actually equal to OB, which is this radius. Do you see that, guys? OE is equal to OB because why? The thing is, radii are equal. Okay. When we have a radius, the radius in a circle are all equal. So from here to here, this is a radius. This radius will be equal to this radius. It will be equal to that radius and any other radius that can be produced in this circle. Those radius will be equal. So we say OE is equal to OB. Now what is OE? OE is x plus 8. What is OB? Remember, guys, we found OB in terms of x. It is equal to the square root of 144 plus x squared. Now, guys, when you look at this, haven't you ever seen this before? An equation of this nature. Haven't you ever seen an equation of this nature before, and where? I want to see if people see the topic. Equation like this, where have you seen it before? Which topic in term 1? Which topic in term 1, grade 11? Even the grade 12 should know which topic. These people are gonna, hey, these people, which topic? Hey, Bana, no one is answering. Everyone is mute, silence. Hey, Bana. Do I have people in here? Hey, these people, no answer. Zimile just wants to come on and ask me about extra lessons. I'm doing a lesson now and I'm asking questions. Do you think that extra lesson, Zimile, will help you out when it's clear that when I teach people, no one is listening, no one wants to answer, no one is actually, flowing with me, because the comment section is so quiet. It's making me scared. It's almost as if like I'm feeling this topic alone. Hey, right? I was asking about the topic, guys. I wasn't asking you what to do next. I was asking, this x plus 8 is equal to the square root of 144 plus x squared. What topic does this remind you of? That's what I was asking. In term 1, grade 11, This is under what? Okay, I see Naji is saying algebra, but specifically which topic in algebra? This is grade 11. Hey bana. Thank you, Snamahle. Yo, Snamahle. Hi, you are a lifesaver, Snamahle. Thank you so much, Snamahle. Really. And specifically, we know it's third equations. All right. So we are back in algebra. And those people that thought they were done with algebra because term 1 is done, guys, I have a sad story for you. And maybe some of you did not really do well in these types of questions. The thing is, term 2 is laced with the application of what you've learned in term 1, right? So yes, I do extra classes. Person was asking, you can contact me on the side. So yes, what do we do then? Sweet Cody says we square both sides. So yes, you're right, we square both sides as per the convention. Then x plus 8, must say x plus 8, guys, is x squared plus 64, right? I just want and the response in the comment section. When I apply the square here, I say x squared plus 64, right? Yeah, the square must here this side, right? It's x squared plus 64, right? Hey, I'm checking the holiday people here. Jean is me saying yes. Yo, people, this is not good. Guys, why do I have a feeling that I have sleepy people in this live? You know, it's like people are just here. You see, now I'm asking questions and people are saying things and they are agreeing to things. Guys, x plus 8, the whole thing squared. It's nonsense for me to say x squared plus 64. We don't do that. We know this is like opening. We open two brackets. And then we FOIL. Yay, Precious, thank you so much for releasing us. X times x, x squared. X times 8 is 8x. 8 times x is another 8x. And then 8 times 8 is 64, which means x squared plus 16x plus 64. And of course, when we square both sides, for what? For a square root, it removes the square root. When we square it, we're left with 144 plus x squared. Now it's a matter of transposing like terms. So the x squared, we take the x squared over minus x squared plus 16x plus 64. All right. Then the 144 we also transpose. 16x is equal to 144 minus 64. What do we get? 16x is equal to what? What's 144 minus 64? My beautiful maths gamers. It's 80, right? Then when we divide by 16 both sides, because that's what we do, we get a beautiful answer of x being equal to okay, 5. But we did not want x, we wanted the length of OB. And remember, what is OB? OB is equal to the square root of 144 plus x squared. So we go and substitute our x value there. Then Mr. Calculator helps us out. This is 169, the square root of which is 13. 13 what? Centimeters. 13 centimeters. That is the length of OB. Okay. Right. So this question, it just required us to work a little bit, but at the end of the day, we were able to get to the nice answer for the second follow-up question, the length of OB. What did we do to get the length of OB? We found the length of OE in terms of x. That was x plus 8. We take the OD, which is x. We took the DE, which is 8. We added these together, x plus 8. That gives us the length of OE. Then OE is actually equal to OB. Why? Because these are radii. We know that our radius is 1. Radii is plural, meaning many radius. Okay, so radii are equal. That's why we say OE is equal to OB. Then the length of OB in terms of x is x plus 8. The length of OB in terms of x is square root of 144 plus x squared. We then solve this using our understanding of surd equations. This is how we go about it. We square both sides. Remember, guys, don't forget what you've learned. A binomial squared means we open two brackets, we FOIL, we get x squared plus 16x plus 64. The square root of 144 plus x squared gives us 144 plus x squared. We then transpose terms so that we can add and subtract like terms. This is a linear equation. We isolate the x term, we isolate the constant term, we divide by the coefficient of the x value, which is 16, and then we get x is equal to 5. But the question did not ask for the value of x, it wanted the length of OB. So the actual length of OB, we substitute the 5 in the place of x because we now know what x is, and then we simplify. We get an answer for OB, which is 13 centimeters. Okay, any questions? Right, I hope that is clear for one and all. That was answering that question for Euclidean geometry. Let's move on to the next one. Okay, this was homework, guys, so I'm just doing corrections before I move into the next theorem that I wanted to touch on for today, so that we can look at some questions around that particular theorem. So here we are told that AB is a chord. AB is a chord. Let's go to the diagram. Here is AB. Indeed, this is a chord. A line that goes from one end of the circumference to another. This is a chord. Okay, then AB is a chord of the circle. Here is the circle indeed. AC is equal to CB. They even have those lines to indicate equality of AC and CB. Okay, then next, and the length of the radius is 5 units. The length of the radius is 5 units. So let's go to the circle. Where is the radius? Here is the radius. It's OA. Indeed, it is 5 units. So it's like they're not lying, these people. There we can see the length of the radius OA, which is 5 units. And that is the only radius we have in the diagram that is actually drawn. Then AC is equal to 3 units. Where is AC? Here is AC. Next, and OC is equal to 4 units. Where is OC? OC equal to 4 units. Now the question, show that OC is perpendicular to AB. Show that OC is perpendicular to what? To AB. OC is perpendicular to AB. And they are saying, and explain why OC, where's OC? OC passes through the center O. Explain why OC passes through the center O. Right. So I hope we can see what this question is saying, and it's sort of important, and hopefully, yeah, we'll see what we have to see. Now the thing is, in this particular question, something very important to note is that we are told that AB is a chord of the circle, AC is equal to CB, and the length of the radius is 5 units. AC is equal to 3 units, and OC is equal to 4 units. show that OC is perpendicular to AB. So we need to show that that is the case. So what were we told, guys? We were told that this is the radius. Okay, so let us do something here. OA, we know that OA, which is the radius, is equal to 5 units. Okay, now what I'm going to do, right, is I'm going to see if whether this is a right angle triangle, because if I can prove that this is a right angle triangle, then that would mean that this angle is 90 degrees. How do I prove that? I prove it using the converse, okay, of the theorem of Pythagoras. Now the converse, guys, the converse of the theorem of Pythagoras, I want to actually send us to a very important document. Just very quickly, I want to show you this. Hopefully people have patience to be shown. Okay, guys, can you see what you can see before your face right now? I'm sure you've never seen such beautiful words. Guys, this is what we call a document that basically contains the acceptable reasons that we use whenever we are wanting to substantiate and give a reason for something that we have done in geometry. This is the document that is utilized when markers mark, even in the marking centers, end of year grade 12 exams. We need to subscribe to these reasons whenever we are giving a reason for something that we have said. I want to turn your attention there where it says triangles. I'm sure you can see there at the top, it says, not at the top, but I mean in the table itself, you have theorem statement and then you have acceptable reasons. Theorem statement in the left column, acceptable reasons in the right column. Then you have theorems that relate to lines. Forget about the theorems that relate to lines. Let's go to the theorems that relate to triangles. And I want you to, from that place where triangles, the theorem relating to triangles starts, I want you to count the number of rows, and I want you to go to the 1, 2, 3, 4, 5, the 6th row. Can you see the 6th row? The one that says, if you read the theorem statement on the right, on the left, it says, if the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then the triangle is right angled. Talk about how to prove that a triangle that is given to us. How do we prove that a triangle is a right angled triangle? I repeat, if the square of the longest side in a triangle is equal to the sum of the squares of the other two sides, then the triangle is right angled. And the reason we use there is converse of the theorem of Pythagoras. I just wanted to bring our attention to this. Guys, this document, you have to have it as a matter of as a matter of urgency. See, I love it when I use these words that basically, would kind of infer to anyone that this is very serious. Very, very serious. So please, as a matter of urgency, guys, you must have this document. Life and you can be happy. So my grade 11s, please, very important. So guys, this triangle, we want to prove that it's a right angle triangle. So that means if I can prove that the square of the longest side, which is OA, by the way, guys, in this triangle, in triangle OAC, I'm sure you guys can see that in triangle OAC, guys, what do you see here? This is OA, the longest side. AC and OC, they are not the longer side, they are shorter than this one. So the theorem said, the converse said, if the square of the longer side is equal to the sum of the square of the other two sides, then the triangle is a right angle triangle. So that's where I'm going to take my Q. Now I'm going to take OAC alone. Then I say AC squared plus what? OC squared. Let's take that alone, just the sum of the two squares of the other two sides, and just check something here. So we have AC, which is 3 squared, plus CO squared, which is 4 squared. And what do we get? We get 9 plus 16, which is 25. Okay. OA squared, on the other hand, gives me what? 5 squared, which is also what? 25. So do you see that the square of the longer side is in actual fact equal to the square of the sum of the square of the other two sides? So we can conclude the following. OA squared indeed here is equal to AC squared plus OC squared. In other words, 25 is equal to 25. Therefore, what can we conclude? Triangle what? OAC is a right angled triangle. Why? Converse of Pythagoras. That's why. So then I can conclude. What can I conclude? I can then now conclude, but because the question said, show that OC is perpendicular to AB. In other words, OC is perpendicular to AB. Isn't that now true? The fact that we said OAC is a right angle and we've proved it using the converse of the theorem of Pythagoras, we can then conclude, therefore, that OC is perpendicular to AB. Done. Talk about the theorem of Pythagoras working here. This is how we prove that a triangle is right angled. We use that theorem statement that says, if the square of the longest side is equal to the sum of the square of the other two sides, which we've seen here, therefore the triangle that is concerned is not just an ordinary triangle, but it is a right angle triangle. Why? Converse of Pythagoras. That is why. So therefore we can conclude that OC is truly perpendicular to AB. Haven't you ever seen such a beautiful sight of mathematical understanding being unpacked in front of your eyes? So this is what is very sweet, crucial, and critical about this particular proof. Nyaki, is congruency also applicable? So here the only problem is that we were not given the other triangle. Okay, and what we try and avoid very strongly whenever we are doing riders in a particular problem, we try and avoid sketching, and making additional sketches. But yes, the idea of congruency would be very much applicable here, if you could. All right. Then the question also says, and explain why OC passes through the center O. Okay, explain why OC passes through the center O. All right, so there's a few reasons, or at least the reason that we can actually think about. Remember, we have now proven that this is a line, that OC is perpendicular to AB, but it can't be the case unless this here is a line from the center. Why is OC passing through the center O? It's because this line must be a line from the center that is perpendicular to the chord. And what does that line from the center perpendicular to the chord do? It bisects the chord. Okay, so that is why, if we are going to explain why OC passes through the center O, it's because this is a perpendicular bisector. OC is a perpendicular bisector, and as such it passes through center O. Okay, OC is a perpendicular bisector, and what does it do? It passes through the center O. That's what a perpendicular bisector actually does. It passes through the center. So very important, and that's how we would answer that very last question. Guys, I hope you loved that. I hope you were good with that. Now we need to proceed to the next beautiful theorem. Are you ready for the next theorem, guys? The next beautiful theorem is coming. So the next theorem, guys, is the following. The angle which an arc of a circle, the angle which an arc of a circle, the angle which an arc of a circle subtends at the circumference of the circle. The angle which an arc, we'll unpack all of this, don't worry, of a circle subtends at the circumference of the circle is twice the angle it subtends at the sorry, there's something that I made here. The angle which an arc of a circle subtends at the center. What am I saying here? Sorry guys, I'm sorry. I knew there was something. The minute I said circumference again, I was like, nah man, something's off here. Something is very off. Okay, prone to mistakes, definitely. So I'm sure you guys are happy as you've seen the sir make a mistake there. It subtends at the circumference. All right. So let us unpack this so that it makes sense. What are these people saying? The angle which an arc. Ooh, what is this guy? What is an arc? Okay, right. So I'm just gonna roughly. I want us to understand what an arc is. So if we know what we know. What did I say? A line like this is called, what is this line called? We call this line, so if this is a circle and it's a perfect shaped circle, guys, please don't judge me. Don't judge me. We listen, but we don't judge. This is the one situation where you're supposed to listen and not judge. Okay, so yes, the line there, we refer to that line as a chord. This is a chord, right? Now this chord makes available something that we know as an arc. Guys, from this side of the chord, okay, just use that. We call this a arc. It's a portion of the circumference, all right, usually enclosed by a chord. So this would be called an arc, all right? And not only that, but we can also refer to this as an arc. Are you with me? So it is a portion of the circumference, okay? And usually the chord, you know, will dictate sort of like from where until where our arc stops and starts. So this is a smaller arc, it's a minor arc, whereas this is a major arc, okay? But it's the distance from this chord, from this side of the chord all the way to this side of the chord. That's how we can identify an arc. And then also here, the green section, all right, from here to there, that segment of, sorry, that portion of the circumference from this side of the chord to this side of the chord along the circumference, we call that an arc. Okay, so I want you to understand what an arc is. Okay, yeah, okay, I hope we are together there. Then the other thing that we need to understand, so this here is an arc, this here is an arc. The other thing we need to understand is this word that they refer to, that is called subtend. So if we have a chord, for instance, okay, I want to ask you guys, how many arcs do you see here? Okay, so this is a chord, here is an arc, one arc, I hope you can see the many chords. Here is another chord, that means this is an arc. Okay, I'm just using different colors so that you guys can appreciate the different arcs that we have. Yes, Sarah, there's 3 arcs. I love that. Then here is another chord. This is an arc. So we have 3 arcs. 3 arcs and 3 chords. All right, I love this. Okay, so we call this an arc, this is an arc, this is an arc. 3 arcs and 3 chords. So our arcs correspond to the number of chords that we have in this situation. Okay, so thank you so much. You guys, I think you are with me. Now, please, 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 please take note of the following. Do you see? Let's look at arc number 1. Okay, you see arc number 1. We can say, when we use the word subtend, you see this arc? You see this arc? You see it? You see Mr. Purple arc? Arc number 1? You see him? Together with his chord, we would call him the purple chord as well. Purple arc, purple chord. They actually subtend this angle at the circumference. That's what subtend means. Okay, this arc subtends that angle at the circumference. In other words, the angle that is opposite this arc is, if I was to put maybe a letter there, I would say it's angle A. Okay, maybe let me not say it's angle A. I mean, I would have to give it the right convention, right? Arc 1 subtends angle AB, angle BAC. I hope you guys understand that. Okay. Right. Now the thing is, this arc subtends only that angle. This arc does not subtend angle CBA, neither does arc BC subtend angle BCA. Arc BC only subtends angle BAC. I hope you guys understand what I mean. If I was to change and go to arc 2, let's say arc 2, my question then would be to you, what angle does arc 2 subtend? In other words, what is the angle opposite that arc? Okay, you can write there in the comment section and you use the letters for convention, guys. Use the letters in the order. The middle letter always denotes the angle you are talking about. So for instance, I said BAC. The middle letter with the cap denotes the angle. All right, so I know you guys might not have the cap in accessibility to you as you type, but I will know in the manner in which you are able to write your letters. So Emza is saying angle ABC, as well as Ms. Zungu. The real gift as well is saying angle ABC. You guys are 100% spot on. So arc 2 subtends angle ABC. And then lastly, what about arc 3? Arc 3 subtends which angle? Okay, now you guys are getting into the flow of things. You're getting into the flow of things. Once you know these things, this terminology, if you know the terminology, you know its application. That's where the beauty is, understanding the simplicity. So yes, you guys are 100% spot on. It's angle ACB. Hundreds. I agree. So we can clap for everyone. I hope everyone is really understanding what we mean by this term subtend. Very important term. So arc 2 subtends, like you guys said, ABC. Arc 3 subtends ACB. Okay, we have it down. So this word subtend only means just that, the angle that is opposite this arc that you are talking about. All right, so this arc subtends an angle at the, so angle BAC is at the circumference. So we say arc BC subtends this angle at the circumference. I hope we are together. So let's go now and reread the statement of the theorem. It says the angle which an arc, so now already in your head, because you have understood what the word arc means, you now know visually, you can see it in your head. Okay, that's what they mean, an arc. So the angle, you know what an angle is, which an arc of a circle subtends at the center. Arc subtends at the center. Say showed me an arc subtending an angle at the circumference. What do you mean now by arc subtending an angle at the center? Let's look at it very quickly. Let's say that is center O. Can you see center O? This is the center. We say this is the center. All right, we are saying it is the center, which would mean, if that is the center, can anyone tell me what OA and OB are? Let's see if people are actually like just flowing so nicely with the geometry. If O is the center, what is OA and OB? What do we refer to them by name? OA and OB are called the what? OA and OB, we call them the what? Nice, Lolo. Hi, Lolo, when? You are doing the things. Okay, so together we call them the radii. Remember, guys, we said plural. You know, it's one radius, meaning OA is a radius, OB is a radius, but together we call them the radii. If you were closer, you would say khadi. We call it khadi. You know, there's the people here that have the clan name Khadebe, you know, and Khadebe is usually spelled with an R. We say it's the khadi. All right, people are featuring even in circles, Euclidean geometry, these khadi people. Anyways, sorry, let's come back. So these are the radii. Now, where is the arc? We have arc what? Arc AB. I can see arc AB. I'm sure you can see arc AB. You can see arc AB. That is not the only arc that is there, of course. There's also the major one, the major arc. all right, because it has to come back to that chord. See that? Okay. But I'm sure you can see that arc AB this time round is not subtending an angle at the circumference. It's subtending an angle where? Arc AB subtends angle AOB. Okay, that's what we mean by subtending. Yeah, you go to the chord and then you just, it's like you are moving in the same direction from A to O, from B to O. That is the angle formed at the center, AOB. Okay, right. For me, guys, it's very important to understand these things, and I know maybe some of you are like, yo, this guy is just dragging this out. Like, I mean, come on, dude, can you just get to the... If the concept is understood, then I go back to my statement: the angle which an arc of a circle subtends at the center of the circle is twice the angle it subtends at the circumference. So there are 3 diagrams which this theorem, we need to know these diagrams. 3 of them, right? The first one is what we call the arrowhead diagram. The arrowhead diagram. This is the center. Okay. So let's just say this was A, B, C. All right. And I'm sure you can clearly see that there is only one arc that subtends an angle at the center. One arc and one arc only. Because as you move in the direction from your points where the arc end, you can see that they both lead into, do you see where they lead into? Okay, where OC and BO are, this arc leads into which angle? This angle. So the angle at the center that they are talking about is this angle. So what is the theorem saying? It's saying the angle which an arc of a circle subtends at the center. Which angle? This one. In other words, angle BOC. I repeat, the angle which an arc of a circle subtends at the center of the circle. What about it? They are saying that angle is twice. It is what? It is twice. What does twice mean? It means it is 2 times. It is twice. Twice means multiplied by 2. Twice means double. So twice means double. Twice means multiply by 2. So the angle which an arc of a circle subtends at the center of the circle is what? It is twice the angle it subtends at the circumference. Now we need to look at that same arc and ask ourselves, which angle is this arc subtending at the circumference? Now, like I said, we move from the direction of the end of the arc. And where does that lead us? It leads us to angle ABAC. So it's twice BAC. So whenever we have an arrowhead like this, the arc will subtend an angle at the center. The same arc will subtend an angle at the circumference. And guys, like I said, it is only arc BC that subtends an angle at the center. The same arc subtends an angle at the circumference. Okay. Now someone else might want to say, what about arc AC? Guys, you can see arc AC is not subtending any angle because you see, arc AB, it's not subtending any angle at the center. It's only arc BC that's subtending the angle at the center, and arc BC is simultaneously subtending an angle at the circumference. Okay. Can I get an amen in the comment section? I don't know if people are flowing with me. If grade 11s, I don't know. Okay, I don't know. So if we read the theorem statement again, the angle which an arc of a circle subtends at the center of the circle is twice the angle it subtends at the circumference. All right, so that diagram, utmost importance, but that's not the only diagram that means angle at the center is twice the angle at the circumference. I'm going to expose you to another one. The other one that speaks the same language is this one. Okay, remember I said this is the arrowhead. 1, 2, 3 at the circumference. The fourth part is at the center. 1, 2, 3 at the circumference. The fourth part is at the center. At the center. I repeat, 1, 2, 3 at the circumference. Fourth at the center. 1, 2, 3 at the circumference. The fourth. So O, please guys, I know this is not drawn to scale, but this is an O meant to be at the center. I usually say this is the diamond. All right, the diamond, the arrowhead, the diamond. Okay, and I'm just going to use the same letters A, B, O, C, just for my convention there. All right, then which arc are we talking about? Nyaki, here's the first circle. There's the first circle. Why do you want to go back to the first circle? Do you just want to go there for the purpose of screenshotting, or do you want to go back there for the purpose of asking? Me, I don't mind guys going back and forth. Just let me know. Please don't allow me to pass through something and you are not clear. Ask questions in the comment section if there's something you don't understand. Harass me until things are very clear for yourself. Circle geometry is such a joy. It's such a beautiful topic in grade 11. And in actual fact, you can even find yourself saying that, hey, Euclidean geometry is actually easy. You can. It's very possible. But it needs you to actually, like I said, you need to grasp the theorem statement, attach meaning to the diagram because of the theorem statement, understand what they mean by the theorem statement as it relates to the diagram, and be able to apply it. If you can do those things, suka, geometry is nothing. You know? Yeah. So please, got the pictures, got Beyonce from the wall, take them down, please. Let's post these diagrams. They need to be there, please. Ne? Okay, Nyaki, are we good? Can I move on? I went back to the first circle. I don't know if you have nyaka'd it enough. Oh no, sorry, guys. Please don't accept any invites. I may have just sent an invite whilst I was trying to, because Nyaki was saying I asked the question. Which question? Nyaki, which question? BC subtends the angle at the center, which is BOC. Please guys, it's this angle, not this one. It's the angle here, all right, not the angle here. It's the angle there. Then the same arc subtends the angle BAC. So that's why we say angle BOC is 2 times angle BAC. Let's move on to the next diagram. Same thing. Which arc? It's arc BC, subtending which angle? This angle at the circumference. Okay, this angle from here to there, this angle at the circumference, it's subtending that angle. The same arc is subtending which angle? This one. Angle at the center is twice the angle at the circumference. So same statement. Angle BOC, this side, the reflex angle, is equal to 2 times the angle BAC. Right? So you see this statement is still relevant for this diagram as well. Okay, I can say angle BOC, this angle, is equal to 2 times the angle BAC. All right? And then the last and final diagram that I need to draw. And please guys, please take note. You see this arc AC, it's not subtending that angle at the center. You see arc AB, it's not subtending that angle at the center. It's only arc BC. Please guys, it's subtending this angle at the center because it's directly opposite that angle. The same arc is subtending this angle at the circumference. Okay, so that's why we say angle BOC, this angle, is equal to 2 times this angle, which is angle BAC. Okay, so that's why this statement is still relevant. That's why I was saying this statement applies to this diagram. This is the second diagram, the diamond, and then the very last and final diagram, I call it the butterfly. Fly, fly, butterfly, or the bow tie, some people call it. The bow tie. The bow tie special. Say hi to the bow tie. Guys, this is the bow tie special. Okay, the bow tie special. Okay, the what? The bow tie special. The what? The bow tie special. The what? The bow tie special. Okay. Right. Any questions so far? I hope if there's any question here. So let's look. Where are the arc in this particular diagram? So we have arc BC, arc BC, arc BC. Right. Please take note. Arc BC. We have arc AC, we have arc OB, but the one that gives us special attention as it relates to this theorem, remember, angle at the center, the angle subtended by the arc of the circle. Okay, so once again, arc BC is subtending which angle at the center? I'm sure you can see it. Look at it. This angle. Do you see it? It's subtending that angle. This is the angle. This one. This arc BC is subtending that angle at the center. The same arc is subtending this angle at the circumference. So in the same vein, angle BOC is equal to 2 times the angle at the circumference, BC is also subtending this angle at the circumference, BAC. See the statement still relevant in that diagram. See the statement still relevant for all 3 diagrams. The third bow tie. Okay. Any serious questions, please? I will welcome those serious questions. This is so important. All right. Guys, I'm not going to really delve into the proofs for each theorem, and towards when I'm done with the geometry, when I'm done with all of the theorems, then I will do the proofs that are examinable. I will only do the proofs that are examinable, and I will allow your teachers at school to basically explore all the proofs, as that is something that they have to do for you. But me, I will only focus on the theorems or the proofs that are examinable. Now, good people, whenever we use this particular theorem, because of having mentioned this statement, what is our reason that we must write? That's what I want to look at now. The reason we ought to write whenever we are using this statement: angle at the center 2 times the angle at the circumference. So I want to go to that document again, because I just don't want to mislead or thumb sucks. You know your theorem statements. It's nice. Okay, not this one. It's not this document that I was looking for. Let's see if I can't I think this. Could it be this one? Yes, it's this one. So under circles, I'm sure you can see in front of you right now. So once again, you have your theorem statement on the left, you have your acceptable reason on your right column. Under circles, where you can see circles, it's in a bold capital letter circles. We are looking at statement number 1, 2, 3, 4, 5, the 6th statement. The 6th statement. By the way, look at the 1, 2, 3, 4, 5. Look at the 5th statement. You remember when we were answering that question that says, why does the line pass through the center? Something about that thing. And there's this theorem that says the perpendicular bisector of a chord passes through the center of the circle. And if you remember, that's the reasoning that I had actually utilized to explain the reason why we can say that line passes through the center. It's because we had a perpendicular bisector of a chord. That basically what does what? It is the one that passes through the center of the circle. Not meant to be a laugh, my goodness. Okay, that was not meant to be a laugh. J-Praise, if you just joined in, then I can understand if you are saying you don't understand this topic at all. Okay, but like I said, people, when genuinely, as we've been going through the topic, please, if there's questions, you must ask those questions. I want to now check the 7th. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's the 6th row, where you can say the statement: the angle subtended by an arc at the center of a circle is double. Okay, remember we said it's twice, but it's double. It's double the size of the angle subtended by the same arc at the circle. Okay, so very important. Okay, very, very important. So there, if you look at the acceptable reason that they've given there on the right, they have angle at center equal 2 times angle at circumference. And that's what we write, because that is the acceptable reason that we ought to use whenever we're using that particular theorem. So this is what we write, guys. Symbol for angle at center equal to 2 times symbol for angle at circumference. And that's that. So whenever we use this statement, because we can identify it from what we see in the diagram, either this diagram or this diagram or this diagram. Like I said, guys, 1, 2, 3 vertices, 1 in the center. 1, 2, 3 vertices in the circumference, 1 at the center. 1, 2, 3 vertices at the circumference, 1 at the center. That's kind of how I remember angle at the center is 2 times the angle at the circumference, because it has to showcase the 1, 2, 3, 1 at the center, 1, 2, 3, 1 at the center, and plus from the statement it has to be an arc subtending an angle at the center for the arrowhead, the same arc subtending an angle at the circumference. Same thing here, the arc subtending an angle at the center. Which angle? This one, not the one inside, the one outside, the reflex angle. The same arc subtending an angle at the circumference. Then here in this diagram, arc BC subtending the angle at the center, which is this angle O, please guys, all of it here, angle O, just this part. The same arc subtending, I hope you can see this arc, that the same arc is subtending an angle, look at this, at the circumference. So that angle at the center is always going to be twice the angle at the circumference, guys. Always, always, always. Thank you, Mbali. Always, always, always. All right. Okay. So let's look at some example. Explain number 2 again, Miss Zungu. Which one? This one. Number 2, the diamond. Here is the arc, Mamuzungu. Okay. See there? From here, enclosed, to there, enclosed. This is the arc. This arc subtends which angle? It is this angle at the circumference, at the center. Okay, this one, just this angle. The same arc subtends this angle at the circumference, this one. So this angle BOC is going to always be twice the angle at the circumference. Okay, I don't know, Miss Zungu, if you are with me, but if you are, please notify me in the comment section, or if I'm losing you, you must say so again. So I'm saying arc BC. This is an arc, guys. Arc BC is subtending, because it's opposite this particular angle. The same arc is subtending this angle at the circumference. So we say the angle at this center is equal to the angle at the circumference, because this arc subtends the angle at the center, the same arc subtends the angle at the circumference. So in all these diagrams, we are saying angle BOC, this angle, the angle subtended at the center by arc BC, is equal to 2 times the angle subtended at the circumference by arc BC. Once again here, arc BC is subtending the angle at the center, this one. The same arc is subtending the angle at the circumference, angle BAC. This arc BC subtends this angle. The same arc subtends this angle at the circumference. So we say angle BOC is equal to 2 times angle BAC. And the reason that we use is this one. Angle at center equal to 2 times angle at circumference. So let's look at some example so that we can see the application of this diagram. I mean, of this theorem, sorry, of this diagram. Thank you, Nachi. Wow, Nachi actually broke his gifting in the public platform. What a joy, like what an honor. Nachi, thank you so much. Nachi Lem ZA. It says you chose to send their first gift ever to your life. Wow, thank you so much. I really appreciate it. That means a lot, because when you are sending your first gift ever on the platform, and you decided to send it in this Maths Live, thank you so much. Means the world to me. Likewise, Badi, thank you so much. Okay, here's a diagram for us. We have center O there. We have B. So we are told O is the center of each circle. Okay, we're going to look at a few. And now we are asked to calculate X, Y, Z, wherever it's found. And we need to also obviously give reasons. Okay? Because in geometry, guys, you know, when the child comes to us and is like, why do people stand? We have to give a reason. Why do you eat with your mouth? We have to give a reason. You know, it's like a reason for everything that you do, especially if it's new and it's not known, you know, and it was never stated before. So here we go. Here we have this here. What do you see here? You see the arrowhead. So this arrowhead should then remind you of one of the three diagrams. This is the arrowhead. Ooh, what do we have given in our diagram? So let's just write down what we have given in our diagram. We have 62 degrees given there. Okay, and we are supposed to find the value of X in the diagram. All right, and what is X? The unknown. It is the angle at the center that is subtended by the arc AB. All right, X is the angle at the center subtended by arc AB, and it just so happens that 62 degrees is the angle subtended by the arc at the circumference. So what is the relationship between this angle subtended by arc AB at the center, the same arc subtending another angle at the circumference for the arrowhead? What can we say as our statement? Something that we see because of the relationship in the angles, because of the arrowhead. What can we say? X, very good, Don. X is equal to, remember, X represents the angle at the center that is subtended by this arc. Are you with me? So X is equal to 2 times what? 62 degrees. Now someone is going to be like, how? Kaloku, we learned angle at center equal 2 times angle at circumference. Yeah? Then all we need to ask is, what's 2 times 62? Ayola Suka just told us it is 124 degrees. And there it is. How straightforward. Okay. Okay. How did that sound? Not too shabby, ne? Not too shabby. Not too shabby. Hey, Noj. Let's look at another one. Example 2. Let's look at another one. One more. Or 2 more. Or 3 more. Okay. What is this one? What is this one? We have O, we have A, we have B, we have C. This time we have Y. We have 50 degrees. Oh, definitely we have Mr. Bowtie. All right. I would say if you guys were going to be going to your guys' respective matric dance, I would say please make sure this time round you have an angle at the center affair, bow tie affair, you know? None of this tie stuff. Bow tie, guys, is the way to go. What a way to represent Euclidean geometry on the metric ball. All right, so guys, 50 degrees there. We want y. So we have a bow tie. What is the 50 degrees in relation to the arc? You know, if you know what I mean. What is the 50 degrees in relation to the arc? And what is the y in relation to the arc? So arc AB is subtending which angle? It's subtending the angle at the center, which is what? 50 degrees. And the same arc AB is subtending which angle? The angle y, which we don't know. So therefore, what can we say? What relationship is there that exists? What can we say, guys? What can we say? Exactly. Angle at the center. You are 100%. Angle at the center is 2 times the angle at the circumference. Andy, you are mixing theorems. Andy, you are mixing theorems. And I am pretty sure that Andy just joined into the live. You were not here all along. Okay. Andy is seeing angles in the same segment. I'm not even there yet. I haven't even covered that. Okay. But for you, Andy, something you are not realizing. And guys, please, that's why I was saying to you, please take note of the diagram. For angle at the center, 2 times the angle at the circumference, we have the arrowhead, we have the diamond, we have the bow tie. And I'm saying this deliberately when I say circumference, circumference, circumference. There's 3 of us, 1 at the center. Circumference, circumference, circumference. There's 3 of us, 1 at the center. Circumference, circumference, circumference. There's 3 of us, 1 at the center. So Andy, since I know you're probably in grade 12, you're probably a grade 12 learner here and you've done this, but now you have forgotten. And I can tell you this one thing, most grade 12 learners that have basically passed grade 11, they forget the theorems and they forget the diagrams and then they mix things up. That's where the mark loss happens. The mark loss is happening for most learners and they're not getting their levels because they are forgetting things that they were solid once upon a time and they knew and understood well. That's why I'm saying, guys, take down the Chris Brown posters, take down the Naledi posters, take them down, put up your theorems, put up your diagrams, have them there in color. Let them romance you, let them entertain you, let them be everything for you. Okay? So if you have that, then it will assist you to be able to keep the things in your mind. Okay? So that's why I'm saying circumference, 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 center. So that's why this is not angles in the same segment. Because if you look at the diagram for angles in the same segment, your bow tie does not have one of the wings touching at the center. Okay? Yeah, and that's the thing, you see. But if you're not aware, you're not going to be aware. So those who are learning this for the first time, you're joining my live now, please listen to the things that I'm saying and listen to them very well. All right, because if you do, then you are going to be fine, because you are going to grasp the concept and then you're going to be able to carry it out consistently, you know. So let's look at this one, like I was saying again. This here, the arc AB subtends the angle at the center. So it is. The same arc is subtending an angle at the circumference. Okay. Guys, please take note. This here is not me trying to do questions of a high level of complexity. I know some of you are probably here and you're like hoping that I can do questions of high level complexity. I am trying to establish the knowledge of the concept first. When you understand the knowledge of the concept around the theorem first, you understand how to apply the theorem statement and what it means for a simplistic diagram. Everything else will be easy. Okay? Yeah. All right. Yes, I'm going to give you homework. It's just that I need to first do some examples before I can give you that. So for this one, what did you guys say? You said y angle at the center is 2 times. So in other words, 50 degrees, the angle at the center, is equal to 2 times y. That's what it means. Angle at the center, 50 degrees, is equal to 2 times y, which is the angle subtended by the same arc at the circumference. We write down the reason, please. Angle at center equal 2 times angle at circumference. And I would appreciate a lack of negativity in my life, because I know some of you come here and some of you can really post some negative stuff. Just if you don't want to be here, please, people, don't stay, leave. Okay, so 50 degrees equal to 2y, and I mean that in the kindest of languages. 50 degrees equal to 2y. We then do what? We divide both sides by 2. Okay, 2y is equal to 50 degrees, divide both sides by 2y is equal to 25. Okay, all right, that's that. Y is 25 because the angle at the center needs to be the one that is 2 times the angle at the circumference. So this angle will always be half this one. Okay, half of this gives me that. 2 times this gives me that. Half of this gives me that. 2 times this gives me that. So that's very important to note. If you know that, then you can always just write the answer and write the reason just off the top. Okay, one more, and then I'll give you, actually I'll do 4 more, and then I'll give you a backload. Say people are hungry for their own, you can leave you to your own devices. Right, now 270 degrees, the angle there. Can I see the first question? Oh, you want to see the first question? This one. Okay, so this was the first question. O is the center of each circle. Calculate x, y, or z in the following diagram. So here there was an x. We had a 62 degrees there. C, A, O, B. And then, that was the first one. Okay. Aisha. All right, and then that was the second one. Okay, please excuse me for not writing circumference fully here. It's just that page space ran out. Thank you, Aisha. Then the next one, this angle 270 degrees. We have O, we have A, we have C, we have B, we have Z. And yes, guys, all 3, this vertices at the circumference, sorry, just me and my squiggly drawing sometimes, that vertex is also at the circumference, and then this guy is at the center. 3 at the circumference, 1 at the center. Now this angle here is 270 degrees, and they want us to find Z. Okay, so sometimes it's very important to take your diagram and you put it in the direction that you know, oh, I see it. Sometimes you have to turn your page. Don't be ashamed to do things like that, guys, until you can see what you ought to see. You see me, I can only see it when it's upside down, because I can see, oh, this is the arc, because this angle is the one that I'm talking about. When we are talking about the diamond, it is this angle, right? 270 degrees, this one. The arc here, AB, subtends this angle. The same arc subtends the angle at the circumference, which is Z that I want. So therefore, how would I go about it? Okay, hope you guys see what I'm saying here. Right, so sometimes it becomes important to turn that paper around. Euclidean geometry requires you to do that sometimes. You turn it around and you see what you ought to see. So what do we want? Z. What is the relationship of Z, the angle at the circumference that is subtended by arc AB, in relation to this angle at the center, which is also subtended by arc AB? What's their relationship? So we would say 270 degrees, which is the angle at the center. It would be then equal to what? 2 times Z. Reason, angle at center equal to 2 times angle at circumference. And then we proceed. Therefore 2Z is equal to 270 degrees. We divide both sides by 2. We know z is equal to 135. Okay, right. I don't think that was too shabby. I think that was actually yeah, pretty fine, wasn't it? Don't you think? Okay. Change around the orientation a little bit, maybe 3 more. I'm gonna do 3 more and then I'm gonna give you yours, guys. Okay, please just bear with me. All right. You see, the thing is, when I teach in this platform, I try to really try and accommodate, because I know some of you are very fast learners, which is cool, but I try to really be conducive for those that I know may just not have okay, sorry, let me just redraw this diagram, because I'm really not pleased with the way I drew that one. 1, 3, then 4. I'm sorry, guys, for these arrowheads. These arrowheads are not arrowing. So if it was 130 degrees, we have CA, then the B here. All right. Okay. We want X, which is that angle there. Okay, arrowhead vibes. Is 130 the angle that we're looking for, that we need to have? Yes. Is X the other angle that we need to have? Yes. What's their relationship? Since it's the arrowhead, 1, 2, 3 at the circumference, this guy is at the center. We are told all those are the center, always the center. So what do we say? Angle at the center, 130, is equal to 2 times the X. What's the reason? Angle at center is equal to 2 times angle at circumference. I know you guys have gotten to the point where you're like, okay, we get the point, we get the point. I know. Once you are there, it means that learning has taken place, and I'm very happy. But now I'm just taking the opportunity to just sort of flaunt it before you, until you are just like, okay, I get your point. And I'm glad you do. So X is equal to 65 degrees. And there we have it. Okay. I'm gonna do 2 last ones. Then I'll definitely give you guys your own. So here's another one. So here we have 23. We have O, we have Y there. We have B, we have C, we have A. So how do we move with this one? It's the bow tie. 1, 2. So we have 1, 2, 3 at the circumference, 1 at the center, which is that bow tie for angle at the center is 2 times the angle at the circumference. The arc subtends angle AOB. The same arc subtends angle ACB. So therefore, what can we say? Y is equal to 2 times 23 degrees. Reason, angle at center. Please slow down, KB. Wow, I thought I was actually going at a too slower pace. Okay, KB. All right. What question? What question do you have? KB. Okay, I've slowed down, KB. Yo. Angle at center is equal to 2 times angle at circumference. Okay, this arc subtends this angle Y. Look, points there, forms angle. Go there, form angle. Go there, form angle at the circumference. Go there, form angle at the center. Go there, form angle at the circumference. So this arc subtends this angle at the center, and it's equal to 2 times the angle at the circumference. So that's why we say Y, angle at the center, Y is equal to 2 times, twice, double, 2 times, which angle? 23 degrees. What's the reason? Angle at the center is 2 times the angle at the circumference. So Y is equal to 46 degrees. Good. Good job, Aisha. Okay, and Ammo. Okay, last one, because you've been sick of it, right? It's like, yo, geometry, so easy. Yes, I know, so easy. Okay, yo, why I feel like my drawing is getting it's getting okay, there we have it. Now we have 126 degrees. We have Z, which we need to find. Z, O, the center, A, C, B. Okay. Okay, can someone answer Liza Mahwana? He's asking which theorem is this one. Surely, Liza Mahwana, if you are asking which theorem is this one for grade 11, even your hand is tired of geometry. That's funny. Okay, so this one, guys, we need to find Z. So once again, what do? We turn it around, turn around, turn around, turn around. The arc AB subtends this angle at the center. We always know it's this angle for the diamond. The same arc subtends this angle at the circumference. What's the angle at the circumference? It's 126. So what's the relationship between Z and 126 degrees? Angle at center, Z is equal to 2 times 126 degrees. You know the reason by now, so I'm just going to leave it. You would write it. Angle at center is 2 times the angle at the circumference. Okay, I'll do that, no problem. Z is equal to, what's 2 times 126? That gives us 252 degrees. Okay, 252 degrees. Okay. All right. We'll call that a cap. Okay, why did we do this? For the purpose of hammering in the concept. Okay, that's why. Very important to hammer in the concept. So who said from the beginning? So these were the notes from the beginning of the angle at the center. Angle which an arc of a circle subtends at the center of the circle is what? Is twice, double, meaning we multiply by 2 the angle it subtends at the circumference. We explained what an arc is. We explained what subtend means. The fact that if this is arc BC, BC subtends angle A because it points from C, and from B it points to angle A at the circumference. If we are talking about arc AB here, it points or is opposite angle AOB. So that's why we say it subtends angle AOB. Okay, so the word subtends means the angle opposite that given arc. Okay, and that's what we mean by subtend. So we looked at the theorem as it relates to the arrowhead. Okay, we said that the arrowhead, BC subtends angle at the center, BC subtends angle at the circumference. The diamond, BC subtends angle at the circumference, BC subtends angle at the, center circumference. Then again, the bow tie, BC subtends center, BC subtends circumference. And that is the acceptable reason we use angle at center is equal to 2 times angle at the circumference. Then we looked at some examples. We were given 62 circumference and x center, arrowhead. So we know from this the relationship is x is equal to 2 times 62. That's the reason, the answer. Bow tie, we have center, arc subtends angle at center, arc subtends angle at the circumference y. What's the relationship? 50 is equal to 2 times the y. That's the reason, that's the solution. Y is equal to 25. Okay, So I'm hoping people are shotting the screen. Let me just switch off the comment section so that people can screenshot in fulicity. Switch off. So people can screenshot in fulicity without being interfered with or interrupted by the comment section. Yeah. Then if we turn over the page, we did some more there. Okay. I'm very sorry guys for the poor picture quality coupled with the poor diagrams, but I hope you guys at least can kind of make out what it is that we had written down. But yeah, this is just a repetition: diamond, arrowhead, bow tie, diamond, bow tie, diamond. Okay, we wanted Z there. We're given 126 degrees. Bow tie. Okay. We don't have Y. We have 23 at the circumference, so Y is equal to 2 times the angle at the circumference. Arrowhead. Okay. 130 degrees is equal to 2 times the X. And then we solve for X. Okay. Yeah, so all in all guys, that's that. I think now maybe the best then beautiful thing for me to do would be to give you guys some game challenge problems, and then we can call it a day and a night and its things. Please don't accept the invitation. I keep on pressing invites by mistake, and I don't want invites. I don't want to invite people. Yes, Gladys. Yes, Gladys Knight. Is it Gladys Knight? Yeah, Gladys Knight. Yeah. Gladys Knight. Okay. So these are game challenge problems. We call them game challenges here. We don't call them homework. We call them game challenges. So let's do the game challenges, and yeah, let's do the things. X so once again, O is the center. Calculate values of X, and of course we know we must give reasons. Always give reasons. Whenever we do. So that's the diagram. That's the first one. The X is what you want there. You're given 60 degrees. So I'm just gonna write all of them, the problems here. Okay, so the X is here on the outside. This is O, the center, of course. All right, just so that. I'm sure some of you are answering the questions as I am going along, and you're like, mark me, sir, mark me. O X PM. Okay, so this is also still the center. Just don't mind, there's actually, let me just redraw this, because it's actually not so indicative of what I've drawn or what I see before me, and I'm very sorry about that. Okay, so that's 6, that's 7. I want to do 8, 9, 10, guys. 8, 9, 10. You know, 10 is a good number. Then you know people have actually really spent some time and they are chilled. Okay, so guys, I'm sure some of you can't see. I'm also trying to be a bit clear there. That's 38 degrees. Okay, sorry about the blurriness of the pictures. Okay, let me just go back from the beginning. So this is the first one. There's an X there. There's a 60 degrees. Then the arrowhead, of course, BAC with the O there. Number 2, arrowhead, AD. There's the O, there's the E. We want X, 24 degrees there. Number 3, yes, you can screenshot the entire, but it's just that it's so hard for me to get a clear picture. I can screenshot there. I'll even take a picture and post in the relevant platforms, or even in the, maybe I can do a TikTok video of this and just put it up now after I'm done. So either or, but screenshot here it is, just that this is as much. Let me remove the comment section so that you guys can. Okay, there we are. Okay, that's as good as it gets from, I can actually show that's up and 1 to 9, and then I think I showed you 10, but this is 1 to 9. I'm gonna do a 10-second countdown because that will mean everybody has screenshotted. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, and that's 10. Okay, and like I said specifically, that's 38 degrees there, that angle. Okay, there it's 70, there it's 100. Okay, let me just write in the letters A, B, C. We've got O, just forgot to write in letters for the others. P, L, M. I think all the others have letters in there. Yeah, that's O, that's B, C, A, O, so that's fine. Okay. Okay, I hope you guys were able to screenshot that. Thank you so much, guys. Thank you so much. Can I now say goodbye officially to you guys? Is it okay if I can do that? Zoom in on 4 and 5. Okay, Aisha, there we are. You're welcome, Ayola. Appreciate your gratitude, and thank you again for the people that actually also sent gifts. Thank you so much, really appreciate it. You're welcome. Yeah, I'll be posting this as soon as I can on the YouTube platform as well, so that those who didn't get it can get it. Yeah, so like I said, guys, this is still like us just understanding the concept. Yeah, but you see, the beautiful thing is it's Maths is a Game. The YouTube channel is Maths is a Game 5 to 7. You can go to my link. There's a link in the bio. There are 2 links in my bio. There's the WhatsApp channel, but not the WhatsApp channel. WhatsApp channel is underused, but you can just use the YouTube channel. Hop on there, and then the videos, the full videos, I usually repost them there so that people can check it out. Okay. Yes, let's just say same time tomorrow. I think this time works. Yeah, this topic, even if you struggled with it, it doesn't have to be a struggle. Okay, so same time tomorrow. Okay, same time tomorrow, grade 11 Euclidean geometry. We started at 7:30. Let's shoot for 7:30 tomorrow. Okay, 7:30. I don't know. Well, 7:30, 7:30, 7:30, 7:30, 7:30. Hey, thank you. Let me love and leave you. Have a precious night, and please do these game activities so that you can see how affluent and good you are with the activities, so that when you move on to the next theorem, at least this is behind you. the angle at the center is 2 times the angle of the circumference thing is behind you. That's what you need. We need to always make sure that we do something, we master it, it's behind us. We do something, we master it, it's behind us. And then when we come back, you know, we can always make sure that we know we are reviewing something that we know very well. Like I said, let the Beyonce posters come down, let the maths come up, let the life science diagrams go up on the wall, let everything that is educational, that you know that you're gonna need someone to remind you, why not utilize your wall to make sure that it is the one that reminds you? Yeah, your screensaver, let it be something that will remind you. Please guys, just do these things so that you can retain. But more importantly, retain them in your mind. You must make sure that your mind is filled with so many good and wholesome things, so that you can make sure that it is able to be a vehicle of retention of things that are important. Yeah, very important, that thing. Okay, thank you. 7:30. Yeah. All right, thank you guys. Let me love and live you amazing grade 11s. Thank you again. I'll see you again.